Welcome to an MTD Technical Corner. I'm here with Alex Newman from First MTA. Welcome to the show, Alex.
Hi Rowan, how are you doing?
Yeah, not too bad, thank you. So today we're going to talk about the Vtec range of 0-point fixturing. Could you first give me a quick overview and a broad overview of the product, please?
So what we have here are Vtec's 0-point pots. This one here is 135mm. They also do a 175mm version that produce up to 30 kilonewtons of grip force each. The main idea with them is 0-point placement of whatever work holding you're putting on the machine bed. So what we've got is we've got two pots here and then two different pull studs, and that just allows me to be able to place things on and off quickly and accurately within 5 microns. So
it's all about the repeatability, and I guess the grip force, you just need to know that it's not going to pull out. Your fixturing further up obviously is what you're going to be focusing on, because that's what's going to be controlling the maybe pull out if you've got some small teeth or something. So obviously you talked about these pots. Now, do you sell these you can get the 4-pot units? Do you sell these pots individually?
So yeah, the pots can be purchased individually and just bolted onto whatever arrangement you want to produce. So you may decide that you want further pitch or them to be closer together. If you really are going really aggressive in, let's say, a horizontal position where you might be more concerned about peel out and stuff like that, you can obviously create a higher density of pots for more grip force.
Sorry, peel out. What's peel out?
So peel out is basically the idea that if you're putting a load of force down on a component or across on a component, it would try and create a rotational force, like a moment that would effectively
try and peel itself out of the fixturing, which is what you don't want here. So you might double up on those pots.
Yeah. So again, what we normally work with is this kind of 200mm pitch, and that seems to work quite well. And then, obviously dependent on the size of the components you're doing, you can either get, a 4 set or a 6 set of them, which then allows you kind of more space and to...
So First MTA obviously they're known for doing a wide range of work holding solutions. Do you think this fits in well with the rest of the range? Do you think this will fit the rest of the work holding solutions and complement those quite well?
I would say that's probably, for the most part, why we originally went out looking for a 0-point product to put into the UK market, was to complement what we do. With the chucks, the vices, the fixturing that we offer up, it may rely on the customer having to swap that over on the machine bed quite regularly, and by having a 0-point system, that takes all that setup time out, which means that you're machining more and ultimately, making more money.
So this is a good foundation for what would you call a modern machine shop that have lots of different kinds of fixtures, but this is the foundation that ties it all together. Definitely,
and if you standardise the spacing of the pots, it means that fixturing can then be moved from different machines, even taking the actual work holding itself over to a CMM if you also had the pots on your CMM, and that way you can kind of measure as you're machining and ensure that you're getting the accuracies needed.
So it's not just applying to a CNC machine, you take it on a CMM and you know that you've not actually moved the part at all. It's still sat in the work holding. So you go in, you take the CMM, maybe a bore is a little bit too small. You can take that back to your machine, not have to set up any more offsets because it's still in the same place.
Exactly.
Do your bore and then you take it back to CMM. So that sounds like, we've got an example here of the part being CMM'd on while it's still in the fixture, just to give an illustrative example. And that sounds like a really good option. Could you put these studs into the workpiece itself?
Yeah, you could put the studs into the workpiece themselves. The way the studs work is we've got 4 different types of studs, 3 different types of studs, sorry. We've got one that is fully constrained in the pot, one that has one axis of freedom of movement, and the rest are just if you had 4 pots, for example, you would have 2 that are purely there for the clamping force. This ensures that you're not over constraining when placing it in. So yeah, that works really well.
So could you just explain that? So you've got 3 studs for the clamping force.
So you have one that is locked in completely in terms of axes of movement. So it's in a set position. The next one would then have one rotational axis so that you're not over constrained, and then so it would lock in a rotation, and then the others, because that is then set in a set position that couldn't be adjusted, the others are purely there for just pulling down the component and holding
and make sure it's not going to pull out.
Exactly.
So you've got absolute reliability in that component itself, and you're only constrained to then the machine spindle power and your cutting tool and your cutting process.
Exactly.
That's fun. Sounds like a fantastic solution. Thank you very much, Alex. That's been an MTD Corner. I hope you've enjoyed it. If you want to find out more about the Vtec solution, then contact First MTA.